Hi, and welcome to my channel. My name is Pamela Johnson. I'm an algebra teacher, and I teach regular on-level Algebra 1 and pre-AP Algebra 1. This channel is usually where I upload videos of lessons for my students when I have a substitute, or currently, now that we have this coronavirus pandemic, it's where I upload lessons that would have been face-to-face previously, and now I upload them to YouTube. That way I can use our video chat time to check in with our students and just kind of answer basic questions that they might have. So this video today is in response to a meme that I keep seeing going around. And while yes, I think it's kind of funny, I also see that there's a real problem. There's a disconnect between the way students are being taught math now versus the way the parents were taught math a while back. Okay. And I just wanted to kind of show you that that disconnect is not really very much of a broken disconnect. It's really just a different way of looking at it, and that it's still the same math. Okay. There's a lot of hate out there for Common Core math. And a lot of it just comes from not understanding the reasoning behind it. So I'm not an advocate of Common Core math. I teach in Texas. But I do want to just kind of share some thoughts with you. So the problem in the meme is 312 times 23. So I'm going to show you the old math first. Back in the day, we were taught that we're going to multiply the 3 first, the 312 by 3, and then the 312 by 2. Okay, so we have the 312 that we're multiplying by 3. When I do 3 times 2, I get 6. 3 times 1 is 3. 3 times 3 is 9. Okay, so we write it as 936 right under here. Now, then we multiplied by the 2, but we weren't really multiplying by 2. We were multiplying by 20. Okay, and what we were taught is because we were multiplying by 20, we go ahead and put a 0 at the end as a placeholder. And as we moved into other place values, we would add zeros as placeholders and then start multiplying. Okay, so 2 times 2 is 4. 2 times 1 is 2. 2 times 3 is 6. Okay, so we had our placeholder in the 1 spot, and then we would write out the rest of that multiplication there. And then we added these things together, these two rows, and got 7,176 is the answer. Okay, that's the way we did it back in the day. That's the old math. Now let's take a look at the way they're doing it now. Okay, the way we're doing it now in many schools is that they're showing them to break it down into parts. Okay, they're having kids break it down into the place values. So the 3 is actually a 300. The 1 is actually a 10, and the 2 is a 2. So 300, 10, and 2. And then for the 23, it was 20 and 3. Okay? And what the new math is showing them with this box method of multiplying is that we're still multiplying each number to each other. Okay? So the 20 times the 300 becomes 6,000. 20 times 10 is 200. 20 times 2 is 40. If I look at this row, this is still 6,240, just like we had over here. When I multiply the 3, it's 930 and 6. Okay? And if I put that together, it's still 936, like we had over here. So, and then it's just adding these together. So we still get the 7,176 as our answer. Okay? There's nothing inherently wrong with either of them. They are both correct methods for multiplying. And what happens is that it's just a different way of looking at it. As a teacher, I see often that our kids don't always learn the same way because our brains don't always work the same way. For some kids, they really need this box to help them visualize what they're multiplying together. For other kids, that box confuses them, but multiplying it the old math way makes a lot more sense to them. So if your kid is insisting that they have to do the box, it might be because that's what makes sense to their brain. Okay? Just like you're insisting that it needs to be this old way because that's what makes sense to your brain. Okay? Now, as an algebra teacher, I've come to find out that there's a link between the two. Okay? If I take 23, and we don't use the x anymore in algebra, we use a dot to show algebra, or to show multiplication, because the x is used for showing that we are, that's a variable, it's an unknown number. So just to avoid confusion, we don't use that. So if I take this 2 and I distribute it to the 312, I'm still going to get that 6,240. And then if I take the 3 and distribute it and multiply it to each other's numbers, I get the 936. So add them together, I get 7,176. This is just another way of looking at it. It's another way to do it. It's not saying that the other two are wrong. It's just a different way to look at it. Okay? As a teacher, I'm a big advocate for there's more than one right way to work the problem. And that's a great thing about math, is that you can work things in different ways and get the same answer. And many of those ways are completely mathematically correct. Okay? Sometimes they're not. Sometimes that way only works for that one problem. But most of the time, there is more than one mathematically correct way to work the problem. Now, in algebra, I told you we got away from x because in algebra, we use x as a variable. So x plus 3 times x plus 5. Okay? When I teach my kids to do this, to multiply these two binomials together, I teach them to distribute like we did with the 20 and the 3 over here. So we'll multiply this x into the binomial and get x squared plus 5x. And then we'll multiply the 3 into the second binomial and get a positive 3x plus 15. And that adds together to give us x squared plus 8x plus 15. Okay? This multiplying that we did over here, where we separated out, we multiplied the 3 first, we distributed that 3 first, and then we distributed that 20, is a precursor to what we do in algebra with binomials. Now, that box method that they showed you up here, that your kid is insisting they have to do because that's how they understand it, that can be used in algebra as well. We could do the box method there, and we'll put an x plus 3 on top and an x plus 5 down the side. And then my x's multiply together to give me x squared. X times a positive 3 is a plus 3x. Positive 5 times x is a plus 5x. And positive 5 times positive 3 is a plus 15. Now, what the kids see is that these two things are like terms and they are diagonal. So they can add those together. And but these two are not like terms. They don't have anything that can be added to them. So we just get the x squared. When I do 3x plus 5x, we get 8x. And then the plus 15 gets written down. Okay. Both distributing, the double distributing up here, what we learned back in the day is FOIL, and this box method are perfectly valid ways of multiplying these binomials together, and we still come out with the same correct answer. Okay. I hope today I've kind of helped you see that there is a reasoning behind doing that box for multiplying. It does help later when we get into algebra and we're having to multiply binomials. It helps kids make a little bit more sense out of it. Even up here on this box, you can see that the hundreds are diagonal to each other and the tens are diagonal to each other, just like our like terms were diagonal to each other down here on the algebraic equation, on the algebraic expression, excuse me. So, next time your child is trying to insist on doing the box method, watch them. Let them do that. You work it out your way and compare answers. See if y'all both got the same answer. If you did, that's the answer. If not, then look to see where the mistake is. Did you make the mistake or did your kid? Okay. I hope this helps clear up a little bit of confusion. That was my goal. And I hope you are doing well. Bye.